wire meters into a circuit. Up here, just for demonstration, I have built a circuit. Anybody want to hazard a guess as to what kind of circuit this is?
Series.
Think it's series? How can I check?
It's in one direction from the wire.
If one bulb goes out,
The rest go out.
the rest go out. There you go. You were correct. It was series. The white wire connecting the two and the two going off were kind of showing a single path. It's hard to see in the camera frame, but yes, it is a single path. So as you are building circuits, wiring meters does not care about which type of circuit it is. How I put the meters on will always be the same. For today's example, it is a series circuit. First of all, the voltmeter. You guys are using digital voltmeters. This dial needs to be turned over here to the left where everything ends with a V. And you notice the little marking on the top of the numbers? That is a marking for direct current, which is what we're using. If you were using this at home, if you wanted to check an outlet to see if it still had a voltage, you would come over here to the wavy line. That's alternating current. Not needed for your lab. I'm going to turn my dial to 20. The 20 volt setting, kind of hard to see on the screen, it's a little fuzzy, is more than my box is able to put out, but less than its maximum output. If I went to 2, my power box is putting out 3.5 at a minimum. I would overload the meter no matter what happened. So 20 is a good place for this lab. You'll notice the voltmeters come with 2 pieces, a black wire and a red wire. Voltmeters, if you check back in your notes, are always wired parallel to the device they're measuring. In other words, they're going to wrap around it on both sides. I'm going to take my black wire and I'm going to touch one side of my light bulb connection. In fact, with this one, I can kind of just hook it in. I'm going to take my red wire. I'm going to touch the other side of the connection. And you'll see my voltmeter now is displaying. Is it light enough to see it?
Yeah.
Kind of, yeah. I'm getting a little over 3 volts, if I can get that one to stay put. And it's really jumping around. Normally it'll settle, there we go, 3.32, 3.33 volts. I'll record that for that bulb. I'll take it off the bulb. I can do it on the next bulb. Touch both ends. I get 2.54 volts. It's different. Ooh.
It's the same parallel, right?
Should be the same in parallel, yes. So another way to know I'm in series, my bulbs were in fact different. And when I go over here and check my power supply, which is off screen, but you should be able to see the voltage, I'm getting around 5.9498. It's kind of balancing. We see it's in the 5.9s.
That adds up.
So in series, yes, those 2 numbers I just measured from the bulbs are supposed to add up to the total. And in fact, question 1, as you're analyzing your circuit, asks you to add up. What should it add up to? The power supply reading is what it should add up to. And then you're asked to do a percent difference comparison. God bless you. My ammeter is an analog meter. It's okay. You need 1 additional wire for the ammeter. Now, Mr. Bell is really good about making meters go backwards. I'm going to, at random, attach my 1 additional wire to the black knob. Ammeters are wired in series. They're designed to measure the current going through the bulb. So to wire it in series, I'm physically going to disconnect the light bulb. Notice everything turned off. It is a series circuit. In parallel, only the bulb you're measuring should turn off. The others should stay lit. I'm going to connect that to the one that ends in 500 milliamps. It's usually a good choice for this lab. I'm going to take that 1 wire I added with the meter. I'm going to bring it back to the bulb. Everything should light up. Oh, look at that. I got it right this time. The needle went up. Yay, thank you, thank you. Yes, that's hard for me to do in live settings. And I did not practice. But since I wired to the ending of 500 milliamps, I'm reading the scale that ends in 500. and noting that it is in milliamps. So as I look at this needle, I see 170 milliamps of current, or 0.17 amperes. That's in series. When I'm done, I'm going to take the wire I took from the bulb off the meter, and I'm going to put it back on the bulb. My ammeter is now free. The circuit is rebuilt. I'm going to come to my next bulb. I'm going to take a wire off of it.
Right, so this is still a series, right?
Still a series circuit. Notice everything went out. I'm going to bring my meter to that bulb. Again, we see the needle rise, and as expected, it rose to the same number, about 170 milliamperes. Because we know in a series circuit, the current should be the same everywhere. But the key here, guys, the device you want to measure, you're going to have to take a wire off of it in order to put the ammeter on it. There is my circuit back. Are there any questions? All righty then. Good luck in your labs. Feel free to call me